Hi, today we're going to talk about stars, their characteristics, composition, and classification. So first of all, let's start with what is a star? What is a definition? Well, one definition is a self-luminous celestial body consisting of a mass of gas held together by its own gravity, in which the energy generated by nuclear reactions in the interior is balanced by the outflow of energy to the surface, and the inward directed gravitational forces are balanced by the outward directed gas and radiation pressures. That might be a little too long though, so here's a better working definition. A hot glowing sphere of gas that produces energy by fusion. And here's a picture of our sun, which is our closest star, and you guys have studied this in your 8th grade science class, or are going to study it in 8th grade science class, so we're not going to go into too much detail on the sun. But this is the star that we probably definitely know the most about, since it's so close to us and we're able to see its surface features. So where do stars come from? Well, they all start in a nebula, which is a large cloud of gas and dust, and eventually it will collapse and start spinning, and most of the matter will gather in the center, and through gravity will start bringing all that mass and matter together and start undergoing nuclear fusion, and then a star is born. And here's a picture of the Orion Nebula here, which sometimes we call nebulas the birthplace of stars. Now let's take a look at the characteristics of stars. We're going to look at the color and temperature, the brightness, and their composition, which means what they're made out of. So color and temperature go hand in hand. The way we're able to tell the temperature of stars is actually one way, the easiest way is by their color. If you think about a flame itself is going to be different colors depending on where you look at in the flame, and the color tells you how hot it is. So blue would be the hottest and red the coolest. And I know that this is a little backwards, for sometimes we associate the color red with heat and the color blue with cold. But when you're actually talking about a glowing gas, blue gases are going to be hotter and red gases will be the coolest. When we talk about the brightness of stars, we call this magnitude. And we assign numbers to them based on their magnitude, and they can be negative numbers or positive numbers. And the negative numbers are the brighter stars, and the positive numbers are the dimmer stars. So the lower the number, the brighter it is. There are two types of magnitude, apparent magnitude and absolute magnitude. Apparent magnitude is how bright the star looks from here on Earth. So for example, because the sun is so close and it appears so bright, it has an apparent magnitude of negative 26.8. Sirius is the brightest star in our night sky and has an apparent magnitude of negative 1.47. Absolute magnitude is the actual brightness of the star, or how much light it's actually giving off. So the sun's absolute magnitude is positive 4.8, and Sirius's absolute magnitude is positive 1.42. So the amount of light that they actually give off, you can see that the sun does not give off as much light as Sirius. Even though it appears so much brighter, the apparent magnitude is so much greater, but that's because it's so close to us. Now let's look at the composition, or what stars are made out of. They're all made of different gases. The inner layers of the stars are very hot and dense, and the outer layers, which we sometimes call the atmosphere, are the cooler gases. So how do we determine the composition? How do we know what stars are made out of? Well, what we do is we look at the stellar spectra. Starlight is separated into a spectrum with a device called a spectrometer, and this is something that you're going to be doing in class, actually using a spectrometer to separate light. A star's light ends up having dark bands across the spectrum. These bands are caused by the absorption of certain wavelengths of light by specific gases in the star. Different bands show us what elements are in the star's atmosphere. They act as a fingerprint. So if we take a look at a star's absorption lines, we can look to see if they have the hydrogen fingerprint in them, and that means that it has hydrogen. So here's an example. There's the hydrogen fingerprint there, and you can see the star spectra, so you can see that since the hydrogen bands line up, that hydrogen is present in the star. Stellar spectra is very important because it tells us not only composition, but it also can tell us about the temperature, luminosity, the velocity and rotation rate, and the mass of stars. There are three types of spectra: the continuous spectra, which is produced by a glowing gas; emission spectra, which is produced when a glowing gas produces spectra only at certain wavelengths, not continuous; and then the absorption spectra, which is produced when a continuous spectra passes through a cooler gas. And now we're going to take a look at an example of all three of these types of spectra. So first, let's take a look at a continuous spectrum. This is the light produced by heating a solid, liquid, or gas to a high pressure, and it can be seen through the spectrometer as a continuous spectrum. So here, over here, we see a hot, solid, liquid, or gas at a high pressure, and as it gives off light, if we use a spectroscope to separate that light into all of the different colors of the spectra, what we see looks like this here at the bottom, a continuous spectra of color. So you see all the colors of the rainbow there. So that means that this light that we might see as yellow light is actually giving light at all of these different colors. Our eyes just combine them all into one. So now let's look at the emission spectra. So this is produced by a cooler glowing gas, and we'll see this as a series of bright colored lines. So here's a gas at a low pressure, low temperature. And again, we might see this light as just yellow or white light, but when we see it go through the spectroscope, we see that it actually looks like down here, this emission spectra, we just see a few brightly colored lines. We don't see the full spectrum there. And next we're going to look at the absorption spectra, which is when you have light produced by heating a solid, liquid, or gas to a high pressure, just like the continuous spectrum. However, it then passes through a cooler gas before passing through the spectroscope. So you can see what happens is you have the continuous spectrum, but on top of it you have some absorption lines, some darker lines. And this is what we see in stars because they have very hot, high-pressure gases in their core, but then their outer atmosphere is a cooler gas that it passes through, so we end up seeing this absorption spectra. So these lines in here indicate for us what these cooler gases are in their atmosphere. So here is another picture of the spectra to just kind of give you an idea about the three different types. So we see the continuous one up here in the corner where we see all of the colors. We see the emission spectra down here where you have the cooler gas giving off light. And here we have the absorption spectra where you have the hot light passing through the cooler gas. And here's what it looks like again. Now let's talk about star classification, how we classify them. In the 1800s, astronomers started classifying stellar spectra. They assigned stars a letter according to the elements that were present in them, but later scientists realized that they were actually classified in the wrong order. So today we use other criteria to order them, and so the letters, they're assigned a letter, but it's kind of random and pretty obscure. The ordering is 0, B, sorry. The ordering is O, B, A, F, G, K, M, and they're ordered by temperature. So they're now classified by how hot they are, and you can see here this is a table of the different classifications. So you can see that the class O stars are blue, which means they're very, very hot, and the class M stars are red, so they're much cooler. And that's it for our lecture on stars.